Welcome everyone to week 4, part 1 of heat and thermodynamics. And in this wonderful, amazing video, I am going to show you how to draw maps when we talk about thermal equilibrium. So first we should talk about what in the world is thermal equilibrium. So thermal equilibrium is when two or more objects of... I'm sorry, my computer all of a sudden started playing music. When two or more objects of different temperatures interact. Now, what does interact mean? It could mean a couple things. It means they could come in contact with each other. They get mixed together. There's different types of heat transfers. There's something called conduction, convection, and radiation. We're not going to get into that, but they're going to interact with one another. So normally we're just going to say like a piece of metal is put in a cup of water. Two pieces of metal are set on one another. They're going to come in contact. They're going to transfer. And what's going to happen is they're going to be transferring heat until there is no difference in temperature. Okay, so when we talk about when two or more objects are interacting, what's going to happen is we have a hot object and a cold object, right? Because there's a difference in temperature. So what happens to the hot object? Well, it cools down. What happens to the cool object? Well, it warms up. So what happened is they transferred heat to one another. So equal amounts of heat are lost and gained in a system. And we call it a system when two or more objects are working together or are interacting with one another. We call it a system. And I will try to make those boxes bigger so you can write in them, because I did not leave enough space for those, so I apologize. So what we're going to do is we're going to draw maps with arrows for these. So when we do this, it's going to be... There's two different types we could go through when we talk about equilibrium. We could start with an object that has a temperature here, and we have a temperature here. So we could say, and then what's going to happen is they're going to meet somewhere in the middle. So we can just say that this object is going to cool down to what we call our final temp. And we can call that Q1. And then we can say this object is going to heat up to that same final temperature, and we can call that Q2. Now, in these situations, and this is what we are focusing on in this lesson, is there's no phase change. Okay, it's just two objects, no phase changes, just gaining or losing heat. So when we talk about phase changes, we're going to be using that Q is equal to MC delta T, because these are temperature changes, not phase changes. Now, that's all great. However, that is not the reality of all these situations. What can happen is we can start with an object that has a temperature. Oops, I forgot. This is temp. This is temp. This should be Q. This is Q down here, and this is Q down here. Okay, so we could start with an object there and there. And depending upon what the object is, what might happen is there might be a phase change that occurs for that particular object somewhere in between. So what would happen is this object would heat up. We can call that Q1. It's going to plateau because we get a phase change. And then that substance is going to continue to heat up. And it's going to meet at that final temperature. And then this is going to cool down. So this is with a phase change. And then what we have to do is we have to use both the Q is equal to MC delta T, and we have to use Q is equal to plus or minus M times L, depending on whether we are talking about the temperature changes, temperature change, then we're using temperature change. But this M times L, this is a phase change. This is good. This is next week, though. Okay, that's next week's lesson. So don't worry about that yet. That's to come. So when, again, thermal equilibrium is when two objects interact, and then the heat gained by one object came from the heat lost by the other. So when we draw these maps, drawing these maps is going to be similar to what we did before. There's just a little bit of differences. So we are going to add the max temp of the system on our y-axis, so max temp. We are going to add the minimum temperature on the y-axis, so we can go minimum. And then we have to ask ourselves, does a phase change occur between these temperatures? If so, we're going to add that dotted line. So we would go something like that. However, I'm going to erase that in just a second because we would have a phase change. But we aren't going to deal with phase changes this week. So, but if there was, that's what we'd have to do. We'd have to go through and say, oh, look, there was a phase change, and then we draw that dotted line. However, that's not this week. So then what we have to do is we have to add a dot at the initial temps of each object. Now, again, two or more objects. So this is going to be an initial temp, and we're going to have an initial temp also down here. Okay, so we have to add a dot for both. One of them is got a bigger temperature than the other because there's a difference in temperature, and that's what causes this heat transfer. So then what we're going to do is we're going to add a dotted line and label it TF for the temperature in which they meet. So I'm just going to, somewhere in the middle, we are going to put a dashed line and say TF. Now, what we are going to do is we're going to end up solving for that. That's what like 98% of the time we will solve for, is what is the final temperature. When we put these two different objects of different masses and different temperatures together, where will they meet? We can actually calculate that and predict that. And then we're going to draw your lines and determine the number of Qs with the system. Now, one thing I want to emphasize when we're drawing lines, it's with arrows. Okay, we need to include those arrows. So if we start with an object here, what's going to happen is it's going to increase temperature until it gets to this TF. And I can call this Q1. And then we have this other object is going to cool down, and we can call that Q2. Now, I called this one Q1 and I called this one Q2. It doesn't matter. We could call this Q1 and this Q2. It's just a way to, it's record keeping. That's all it is. And that's how we draw a map. And that's really the whole entire focus of this week's, this part's lesson. Now, some of you may be saying, well, what's the difference? So we have two different equations. This is the equation we have been using, and it's the sum of all my Q's is equal to question mark, and we've been solving for that question mark. Now, what we've been asking is how much heat is gained or lost. But this time, what we're going to be saying is what is the final temp of two or more objects. So that's really the key here. Is it one object or is it two or more? If it's one object, we're going to use the sum of all my Q's is equal to question mark, because the question is going to probably be how much heat was gained or lost. And if it's one object, we're going to say sum of all my Q's is equal to question mark. However, if it's two or more, that's our thermal equilibrium problem. And that's where we're going to say the sum of all my Q's is equal to 0. Okay? And we're going to be asking, like, what's the final temp? So how do these two look? How are they similar? How are they different? So if we're talking about one object, this is where we had our max, we had our min, and what happened is we had then, like, say, a phase change in here. And then we went Q1. We went Q2. And then we went up to oops, I forgot to put my dot up there, Q3. Okay, and we add them all up and we solve for this question mark. That was previously. Now what's going to happen with these thermal equilibrium problems is we're still going to start with a minimum. We're going to end with a max. But now we're going to say, well, now there's a final temperature here. And we are going to have starting initial temperatures in each locations. And this object, calling randomly Q1, is going to cool down to that T line, and this one's going to heat up and it's going to go to Q2. And then when we set this up, we're going to say the sum of two or more objects. We're going to say the sum of all my Q's is equal to 0. So we're simply going to say that this is going to be Q1 plus Q2 is equal to 0. And that's the idea. We're not doing that yet, but that's where we're heading. So here's a couple quick examples. The couple things we want to keep in mind is it a sum of all my Q is equal to question mark, or is it a sum of all my Q is equal to 0? Is it a temperature change? Is it a phase change? And remember, when we talk about temperature change, it's final minus initial temperature. Okay, but for today, this week, we are drawing a map and determining how many Qs there are for this section of this week. That's it. Okay, so keep that in mind as we're going through these examples. So what we have is we have a piece of lead that has a mass of 1.5 and a starting temperature of 95. Okay. Now I'm in Notability. If you want, this is a great option to kind of go through and download some stuff and highlight and annotate questions along the way too. And it's free on self-service. So we have 1.5 kilogram piece of lead, and then we also have a 1.5 kilogram container of water that starts at 15 degrees Celsius. Now, this is very intentional at 1.5, 1.5. Now, what a lot of people think is they're going to meet in the middle, and that's true. They're going to meet somewhere between. And let me emphasize that they're going to meet somewhere in between, not necessarily in the middle, because if we look down here at our specific heats, even though they have the same masses, remember when we talk about MC delta T, this C is a specific heat, and if you look at the specific heat of water compared to the specific heat of lead, they are very different. So what's going to happen is the overall temperature is going to be closer to the water because it has a higher specific heat than the lead, just so you know that. So we're going to go through, we're going to draw our map. We need to place our maximum temperature, which if we look at the options between 95 and 15, we say, well, which one is that? That's the maximum is that 95. This is my temp. This is my Q. And we're going to say what's my minimum? It's going to be 15 degrees Celsius. Okay, so that's where we're at. So then and this is all referencing this whole thing, right? So we added the maximum temperature, we added the minimum temperature. We're going to ask ourselves, does a phase change occur in between those two? So does a phase change occur of lead or water between 95 degrees and 15 degrees? And the answer is no. It's always going to be no this week. Just this week the answer is no. But we should be asking ourselves, is there a phase change? And the answer is no, there's no phase change. Okay, so we don't have to draw a dotted line. Then we need to add a dot for the initial temperatures. And then we are going to add a dashed line. So we are going to add dots for the initial temperature of my lead. And this is up here. This is my lead. And this was my water. Then we are going to add a dotted line and label TF for the temperature that they're going to meet at. Now, really, it doesn't matter. This is just a map. It's a model. It's really going to end up closer to the water, but it's somewhere in between is the idea. So we have a TF somewhere. Okay, so we drew in our dotted line. And now we're going to draw on our lines and determine the number of Qs. And don't forget, we need to include arrows with this. So we have, let's go green. We have this water that's going to heat up to some TF, whatever that TF is. And we're going to call that Q1. So that water is going to gain heat, right? It's positive. It went up into the right, so it's positive. And then we have this lead that's going to cool down, and we can call that Q2. And that's what your map looks like. That's it. That's all I'm going to ask. Now, what I'm going to also ask is on your quiz for this section, I'm going to ask you to draw this on a piece of paper on your iPad if you want. I suggest a piece of paper. It'll just be easier. And you're going to take a picture of this, and you're going to upload it to the quiz. So I'm going to give you a set of information very similar to this stuff up here. I give you some masses, I give you some temperatures, I give you some substances, and I'm asking you to draw a map, and you're going to take a picture and then upload those pictures into the quiz. Now I'm going to have to manually grade the pictures, so it's going to take me a little bit to get through them, but just that's the quiz this week for this section. Okay, let's try one more together, and then I'm going to have you pause it and do your own. So we have, going to get the highlighter out, we have a piece of aluminum, 50 degrees, 3.5. So we have a 3.5 kilogram piece of aluminum at 50 degrees is placed in 5.5 kilogram, is placed on a 5.5 kilogram piece of 20 degree gold. So we have gold and we have water. Now we aren't using those, just a good habit to get into, that's what we're looking for. So we have two objects that are interacting with one another, so therefore this is the sum of all my Q's is equal to 0. My aluminum is going to lose heat, my gold is going to gain heat. So we draw our map, we have a temp, oops, that's a Q, I'm sorry. We have Q and we have a T. We go through and we add our maximum temperature, the biggest number is 50, the smallest temperature is 20. We look at it and say, hey, does a phase change occur of gold or aluminum between 20 degrees and 50 degrees? And the answer is no. Then we can go through and we can add a dashed line somewhere in between and say, hey, look, there's going to be a TF. We can go and then place our starting temperatures at 50 degrees, and this is the aluminum, and 20 degrees was for the gold. I don't want to use green. And then what happens to my gold is going to heat up, and we're going to call that Q1. And we are going to take my aluminum is going to cool down, and we can call that Q2. And that's my map. Try this one on your own. A 0.5 kilogram piece of aluminum at negative 5 degrees Celsius is placed in 2.15 kilograms of water at 85 degrees Celsius. Is placed in water. Draw a map. How many Q's are there? Now, again, is there a phase change? The answer is no. There's no phase change. So hit pause, draw your map, unpause it. Let's see what we got. All right, so your map. Oops, highlighter. So we have aluminum, negative 5.5. We have 2.5, 85, and we have water. So we have water. We have aluminum. That's what we're looking at. Two or more objects interacting. Therefore, sum of all my Q's is equal to 0. We have our Q. We have our T. We place the largest temperature, the maximum temperature of the system, which is this 85 over here, 85 degrees, and we're going to place our minimum of negative 5 degrees over here. Now, could a phase change occur? The answer is yes. Water could freeze if we were to get, I'm going to erase this in a second, if we were to get all the way to here, we would have a phase change that would occur. It's not going to happen in this section in this week's, just so you know that, but it could, right? It could potentially, that really cold aluminum could cause my water to freeze. If you look at the masses and you look at the specific heats, I hope you realize that that's not going to happen, but it could. And then we can go through and we can say, well, it's going to meet somewhere in between, and I'm going to start with my initial temperature of 85 degree. Water is over here, and my initial temperature of my aluminum is over there at negative 5. Now, what happens to my aluminum? My aluminum is going to heat up, and we're going to call that Q1, and my water is going to cool down. We're going to call that Q2. And because it's an equilibrium problem, Q1 plus Q2 is equal to 0. These are all temperature changes, no phase changes this week. Okay, so that's that. Try this one on your own. Hit pause, read it yourself, then unpause it, and we'll run through it. All right, highlighter, 0.6 kilogram piece of iron at 40 degrees is placed in that's too similar in color. 0.3 kilograms of water. Okay, so we have water and we have iron. Oops. Iron. Okay, we're drawing a map though. So we have Q, we have T, And we can go and then say, well, where does this start and where does this end? So we have a maximum temperature of 40 degrees. We have a minimum temperature of 5 degrees. No phase changes of water or iron will occur between those temperatures. There's my final temperature, going to meet somewhere in between. We're going to make it initial temp dot over here. Now this is for my iron at 40 degrees because that was over at 40. And we're going to go through and we're going to say water. This is my water, started at 5 degrees. And then we can go through and we can draw our lines. And what's going to happen to my iron? My iron's going to cool down, and I call that Q1. And my water is going to heat up, and I can call that Q2. Now, if you notice, I'm flipping Q1 and Q2 all the time. Like over here, I said my iron, the one cooling was Q1. But here I said the one heating up is Q1. It doesn't matter. It just, again, it's just record keeping. It doesn't matter whether it's Q1 or Q2. And that's all there is to drawing maps. So you should go and draw to now do your homework. The sheet called Drawing Maps with Thermal Equilibrium Problems, No Phase Change Worksheet. Then there's a quiz, and again with that quiz you're going to go through and you're going to take pictures of those maps and you're going to submit those. If